Hey everyone, so India's space program just made a huge leap forward. We're talking about a major breakthrough for the engine that powers their mightiest rocket. And it's a development that really redefines what's possible for ISRO, the Indian Space Research Organization. So let's dive right in.
Yeah, this isn't just some small tweak. It's like they've literally unlocked a new superpower for this rocket. It's a fundamental shift that opens up a whole new playbook for what they can do. But what is this new capability, really? Okay, the secret sauce here, it all comes down to two words: Bootstrap-Mode. Now, I know what you're thinking. That sounds more like something from your computer's startup screen than a rocket engine, right? But stick with me here because we're going to break it all down and you'll see exactly why this is such a massive deal. All right, first things first, let's look at the big test that made all of this possible. So, not too long ago, ISRO put its most powerful cryogenic engine, the CE20, through a really crucial test. Now, the goal wasn't just to, fire it up. They've done that a ton of times. The real challenge here was to prove it could shut down and then, and this is the key part, restart while it's just coasting along in the vacuum of space. Okay, to really get why this engine is so important, you've got to meet the absolute beast of a rocket it powers, the LVM-3. So you see, the CE20 engine, it's the workhorse for the upper stage of the LVM-3. You've got the huge boosters that get the rocket off the ground with all that fire and fury, but this engine, it provides that final, super precise push that sends a satellite or a spacecraft exactly where it needs to go, way out there, far from Earth. And when we say this thing is a heavy lifter, we are not kidding. The LVM-3 can haul a whopping 8,000 kilograms up to low Earth orbit. To put that into perspective for you, that's like launching 5 big SUVs into space all at once. That's some serious muscle. And this rocket, it's not just about raw power. It is incredibly reliable. I mean, just look at its track record. It's the rocket that launched the historic Chandrayaan-3 mission that landed on the moon. It also launched its predecessor, Chandrayaan-2, and it's done a whole bunch of commercial satellite launches for OneWeb. This thing is a flight-proven, dependable workhorse for sure. So what's the secret to the CE20's power? Well, it all comes down to the super chilled fuel it uses. So let's dive into the world of cryogenics. Okay, so at its heart, a cryogenic engine is actually pretty straightforward in concept. It just means it runs on propellants that are normally gases here on Earth, right? But to make them super potent, they're chilled down to insanely low temperatures until they turn into liquids. For this engine, we're talking about liquid hydrogen as the fuel and liquid oxygen to make it burn. So why go through all that trouble? Why freeze your fuel? Well, the payoff is absolutely huge. Cryogenic engines are just way, way more efficient. Because the propellants are so dense when they're liquid, you get a much bigger punch for every kilogram you carry. Plus, they're better for the environment. The only real trade-off? They are incredibly complex and tricky to build and operate. And this kind of tech, it puts ISRO in some very, very good company. The specific design of this engine, it's called a gas generator cycle, and it's the same fundamental approach used by some of the most successful rockets in the world. We're talking Europe's Ariane 5, SpaceX's Falcon 9, and China's Long March 5. This is top-tier stuff. All right, so we've got the engine, we've got the rocket. Now it's time to circle back and solve that mystery from the beginning. What in the world is bootstrap mode? The best way to think about it is right there in the name. An engine in bootstrap mode is literally pulling itself up by its own bootstraps. It's a self-starter. That's the core idea. So to get just a little more technical, it's a way for the engine to get up to full, stable power all by itself without needing some extra separate startup system to give it a kick. Everything it needs to get going is already built right in. So here's how that works. First, the start command is given. Now, instead of some separate battery or power source kicking in, the engine cleverly siphons off a tiny bit of its own propellant to get its powerful turbo pumps spinning. Once those pumps are going, they start force-feeding the fuel and oxidizer into the main combustion chamber and boom, the engine roars to life and hits full, stable power, all by itself.
Okay, so a self-starting engine sounds cool, right? But what's the big deal? Why is this such a huge milestone? I mean, what can ISRO actually do now that they couldn't do before?
Well, the answer really boils down to two words: mission flexibility. And I'm not talking about a small improvement here. This is a massive upgrade in how versatile and capable this rocket is. It basically opens up a whole new playbook for their space missions. So think about what this means in practice. The LVM-3 can now fire its engine, shut down completely, just coast through space for a while, and then fire it up again. And it can do that multiple times in one mission. This basically turns the rocket's upper stage into a kind of space tug. It can drop off one satellite, then coast to a totally different altitude or a different angle, and fire up the engine again to release another satellite in a completely new orbit. And for deep space missions to the Moon or Mars, this allows for way more complex and efficient trajectories. So when you put it all together, this successful test isn't just about a piece of hardware. It is a really powerful statement. It shows off a super high level of technical skill and really solidifies India's position as one of the world's leading and most innovative space powers. You know, this breakthrough gives ISRO a more capable, more flexible tool than they've ever had before. It really is a game changer. And that leaves all of us with one really exciting question to think about. With this new superpower now unlocked, where will India's space ambitions take them next?